Hello ladies and gentlemen, today we'll make a nice video about how a piece of simple software helped Metalworks company to do a lot of profits and automate a lot of routines, including designing, machining and other stuff using NC units and in general accelerate the production. With this simple piece of software, let's make a simple drawing for one rectangular panel, width of 1000 mm and height of 500 mm. The thickness of the metal sheet is 1.2 mm and the other parameters are just the bending angles. We don't have an Excel file yet. Let's make a testing save for this. So we open the Smit Dxf test folder. I like a test folder where we will put all the test drawings. And let's all check this with AutoCAD application. Basically, it's a candy wrap of a panel which will be cut on the special power tools with NC unit. So you create a DXF drawing which is exactly an input for the tool. After that, you have to bend the candy wrap into a metal panel which will be used in the facing of some buildings. So this is the corner with with a very big zoom. If you want to check the size of this is 5 mm. And this is a special corner circle which is used to prevent metal from breaking at the bending point. Like if you remember, the first airplanes made of metal broke in the middle of the windows, broke in the corners of the windows because these corners were sharp. So they decided to use circular windows for airplane construction. Like they are no longer rectangular. So in these corners you will make this angle because apparently will be a picture of cracks of metal if you bend it under this straight angle. So yes, this is the entire drawing, the drawing for the panel, rectangular standard panel. If you want to create a number of these panels, so you have to make an Excel spreadsheet for these numbers like K01, K02 for the names of these panels. Let's make 18 of these panels. So you will have 500, 510, 120 as the height of these panels, and maybe the same pattern for the width of these panels. Normally you will copy and paste these parameters from somewhere. Let's make a reverse order for the width of these panels, so they are not just growing up and down. They will be changing the shape. And after we have a set of these panels, we could create a number of drawings up to 3000, which will be calculated around 1 minute, I believe. So we save these files by this Excel document, and at our test folder we receive 18 drawings. Each drawing should be checked with AutoCAD. Yes, if you add these panels here, you will see there's another standard panel. And we can make like thousands of rectangular panels, send all this data to the operator of the NC unit, and he will, using his own software, built in software into his NC unit, he will use all these files to arrange them into a sheet of metal. Like he has a sheet of metal which may be rectangular shape like this, and all these panels will be optimally arranged with another software which is not developed by me, but not a big deal to develop one. So his software will arrange these panels on the sheet of metal, making sure there's the waste of the material is as low as possible. Yeah, especially after he gets all the materials he needs. So what else is interesting about this software? We can also create non-rectangular shapes. So we have a set of panels. Let's make only one panel. And the parameters of the non-rectangular shape are here. So we save all the documents, and let's check the T panel. The T panel must be here already. You could technically create thousands of these panels, and you will see that the drawing is like this. It's a trapezoid shape panel. The same will be for another shapes like triangle shape, or like sected rectangulars, the corner shape. The corners are especially different because you will need to make sure a bending on the 60 degrees, on the 90 degrees. There should be. This line is dashed line is just a place of bend. So if you check these two positions, they will be bent L shape. And how do they look as a candy wrap? Let us see. Yes, there will be the bending. The bending line will be here across the middle of this safety circle. That will prevent a metal from cracking. So what's the point? There are special physics formulas for bending of metal, and you need to make sure the dimensions of all these sides for these panels depend on the thickness of metal. There's a high mathematical and physical formula for this. And the centers of this circle, actually the centers for the sizes of these panels, but with correction on the thickness of metal. Well, if you use Autodesk Inventor or SolidWorks, you could easily build these panels and see how they look bent. To see how they look bent, there's a small explanation over here. The explanation is that when you bend the metal, this will happen to your circles on the corners, or these. So the metal doesn't crack. And when you extend, there are formulas. When you bend them, there are formulas how metal stretches. And there's a small radius of bending, as you can see. So to make sure the panel will be of the exact same size that you want, you need some strong physics and mathematics. This is what actually this software does. It checks physics and mathematics. Yes, and the other type of these panels are the confined type with confined joints. So you create the candy wrap for the confined joints. Let's say conf1 with 500 altitude and width of 1000. Let's see the conf. Yes, these triangles are all of a different shape, and they are generated with some designing software. So when a person comes in and says we need 3000 different triangles, please make us as fast as possible. So we use the software, special offline version for this software. Yeah, and I need to notice that this software is cloud protected. It cannot be stolen, and it's subscription based for customers. Well, I hope you liked this entire video, and I'll make more videos for you. Maybe I'll make some tutorials how to become a coder, industrial programming guy, because it's really a trend bringing in more automation in our life and for our work. Thank you, and leave your feedback in comments, please. The entire confined panel with confined joints looks like this, and their connections are hidden by the bending the lower side of this panel. So if you check it in the internet, you will see a picture like this. This the lower bending in here. This one, it covers all the bolts. So you don't see them when you look on the facade, on the building exterior. That's very useful, and it looks perfectly. The only drawback is when you want to fix something about your building, you need to remove the entire column of these panels. You will have to take away all the columns. So when you check, when you create generic panels of standard size, this piece of software is priceless. It will let even the managers to quick replace some parts or order some parts in the production without calling the engineers to work. And what else? There was a case when an architect ordered a number of generic triangles for his piece of passage arc. This is actually the ceiling of the passage arc, and when you come to the idea that it will require weeks and months of work to design every different triangle. There are 6,000 elements and 3,000 different positions. You may have a problem. Well, with a piece of software, we did it like in a minute. We made a special offline version for this with generic triangles. Just copy paste parameters and create 3,000 drawings for further machining. This saved a lot of time and brought a lot of profits. Well, if you like this, post some comments. Also post some comments if you'd like to see more videos like this, and maybe you would like to have some coding lessons for an industrial coder. Maybe you will have some clues how to become an industrial coder. And so leave your comments in case you want to see more videos about making code, making software and selling software. Thank you for your views.